Thank you. And as you can probably tell, I'm not using a microphone. Can you hear me? Okay, good. We're good then. I have 138 slides, so I may go kind of fast on some of these. One of the first of all, thank you for inviting me and for having me here. The place is great and only slightly colder than Texas. So thank you for having me here. One of the first things that people want to know whenever there's a group of people who are at a talk or a conference or a workshop on anything having to do with creativity is someone raises their hand and they say, well, what is creativity anyway? And then you're done. The whole thing is ruined because that's all we talk about the whole time. And in the end, no one knows anything more than we did when the person first asked to talk. So I'm going to just get it out of your system and say, and tell you what creativity is anyway. I'm going to start, this is an outline of the talk. I'm going to talk about creativity and cognition. I'll tell you what cognition is. I'll talk about incubation effects, which is the puzzle that got me started in studying creative thinking. I'm going to talk about fixation as the problem or as a set of different problems. I'll talk a little bit about a theory because you're engineers and maybe you'll like that. And then some possible solutions to the problem that I'm going to be talking about. So on creativity and cognition, what is creativity? I Googled definition of creativity. I got 154 million plus results. I'm going to go over each one of them, but briefly. No, here's a couple of them. A mental activity performed in situations where there's no prior correct solution or answer. You don't know anything more now than you did after reading that. The generation of novel, useful ideas. That's a pretty good one. Here's one. Creativity is a central source of meaning in our lives. Most of the things, okay, on and on. And so this is one of my favorites, the playful misuse of knowledge. This came from Roger Schenck. And I think this is a really nice one because it emphasizes a couple of things. One is you have to have some knowledge for whatever it is that you do to be creative. If there's no knowledge involved, it doesn't work. Some people take away from my talks, sometimes, he said, oh, knowledge isn't important. It is important, it's essential. It's a rare number of times where the knowledge leads you in the wrong direction. That's what I'm going to be focusing on. So, here's a definition that I use as a family resemblance definition of creativity. A family resemblance, I'll explain in a second. The required characteristics of something that's creative, it has to be novel. If it isn't new, it isn't creative. You copied it, or it's something that we have again. And it has to have some usefulness, if not now, sometime in the future, or practicality or value of some sort. And people argue about whether that's really an important quality. Then there's a set of shared characteristics. That's what a family resemblance definition means. The members of families share common sets of characteristics, but there's no one individual characteristic that you have to be a member of that family or that all the members of that family have. In the family of things that are called creative, there's a lot of different qualities like ambiguity or insightfulness or flexibility or meaningfulness, and many creative ideas have these qualities. Not all of them have all of them, and so this is a way to roughly think about what creativity means. Okay, there are many different levels of creativity. We can talk about creativity that is historic, or creativity that works for a society or for a particular scientific paradigm at an institution or at the group level, at the individual level, or the task that you're doing in some laboratory task, for example, a cognitive process or some biological definition of creativity. And in the study of creative cognition, I and some of my colleagues have focused mostly on these levels, at the level of the group and primarily the individual, the task and process level. But now there's a growing number of researchers looking at biological processes. I'll only touch on that for a few seconds at the end. One question that people have is, are these levels related to each other? If you give someone some laboratory task, they're working on an insight problem, for example, does that have anything to do with historic creativity or the creation of a new paradigm. And that's something that I've tried to address, at least to some extent, in my research, and I'll tell you a little bit about how I've done that. There's many different ways of looking at creativity. You can look at the history and the motivation. There's many different approaches to it. Creative thinking or creative cognition is certainly not the only way. Some people focus on creative products. For example, when you see a creative product, you say, wow, that's really creative, that's really cool, we get it. You can focus on that. You can also focus on creative people. People love to focus on creative people. Wow, wasn't Leonardo unbelievable, or Einstein, or whoever it is? I could never be like that. Well, I don't believe that that's necessarily true. I think that creative people, people who are historically creative and make great contributions, yes, they're special people, yes, they have lots of knowledge, but there's nothing magical about it. So my interest is in creative cognitive processes. If we can figure out what are these incredibly creative people doing, what are they doing in their mind, cognitively speaking, can we distill that? Can we make that into something that we can teach people? Now, a little bit about cognition and cognitive psychology. You've heard the word cognition. What is it? It's pretty easy. Cognition means thinking. Cognition refers to the mind. That's it. Whatever's going on and thinking in the mind. Now, if you walk out of here and you said, oh, cognition means the brain. No, that word isn't on here. Yes, there is a brain that's involved in cognition. You have to have a heart that pumps blood, you have to eat food, there's all kinds of things. But cognition is the thought itself, the thinking. Now, does that really exist? Let's not waste an hour on that question. Yes, thinking exists. You have your own thoughts, etc. Take my class if you don't believe it, or go to the psych department. Think of the brain as hardware, and we call it usually wetware because it's kind of wet. And then cognition, think of as the software. You get the difference between hardware and software. The same piece of hardware can run all different kinds of software. The same software, thank goodness, PowerPoint runs on different hardware. So they're different things. They work together, but they are different things. I'm talking about the software, okay? Where is the software? You say, well, it's in the computer. Well, what if you write it down on a piece of paper? Or what if you put it on a USB? Where is it? Okay, it's a silly question. We're not going to worry about that today. Okay, so the two principles of creative cognition, as my colleagues and I have talked about, the two principles are, the first one is kind of obvious, that creative thinking, that cognitive processes underlie creative thinking. It almost has to. All right, so when you think and you do something creative with your mind, there's cognition going on there. That's what I'm going to talk about. But the second principle, I think, is a little more subtle, that cognition itself is inherently creative. This is a case that I'll make very briefly, but I'm not going to go on with this. But I'll get on with that. The first thing I want to make clear is there's no one process that we would say, this is the creative process. And it's in this part of the brain, and it does this. Sorry, that does not exist. There are many, many, many cognitive processes that collaborate, and they work in various kinds of ways to give us very different kinds of creative products. So it isn't a single process. It doesn't work that way at all. Okay, in the study of creative cognition, I'll talk about some of these different cognitive processes and the way that they underlie creative thinking. But cognition itself is inherently creative. For example, we have concepts and categories in our minds. And when you see a new member, you see a new person that you've never met before. And they fit into a category that you already have. We can extend categories and combine categories and concepts. We can use visualization in creative ways. Memory, how can memory be creative? Well, if you've heard, for example, of false memories, where do those come from? They don't come from alien implants. They come from a creation of the mind. False memories are created memories. They're created in the same way that accurate memories are. The only way they differ from accurate memories is that they don't correspond with reality. The cognitive processes involved are the same. We have creative problem solving, creative use of language. So these and many other areas of cognition all participate in the generation of creative ideas and creative products. I'm only going to talk about a very small subset of these as we go. So why do we need to study this at all? Well, if you want to know how to train people to think more creatively, we've got to distill what some of the processes are, perhaps that everyone agrees consensually. These people are creative. Here's what they're doing. We can train other people to do that. If we want to create new tools to support creative thinking, for example, digital tools that will provide a platform for certain kinds of creativity, they can be based on your understanding of how cognition it works itself and how cognition needs to be supported. And of course, to support the process of creative design, which I assume is what many of you are interested in, and I've been a little bit interested in. I should also confess that I know almost nothing, maybe nothing about design at all. I know just about nothing. I've never taken an engineering class, so I'm making all this up as I go. Okay, so here's the puzzle that got me interested in this work in the first place. They're called incubation effects, and the name incubation is a very misleading name for this effect. What it refers to are for example, these historic cases of insight where Archimedes is working on what's the volume of this crown and trying to figure out if it's fake or not. And he sits down in the bathtub and suddenly has an insight for the displacement principle, and then he stands up out of the bath and invents streaking in the next moment. So two creative discoveries in one. And he wasn't even working on those problems. We have James Crocker, who was trying to figure out how to fix the Hubble Space Telescope. He gets they have meeting after meeting, he can't do it. He takes a shower, he adjusts the thing, he says, hey, that'll work, and it did work, okay? Kekulé figures out the structure of benzene dozing in front of the fire. De Mestral's taking a hike with his dog when he figures out an idea for Velcro. Poincaré discovers the Fuchsian functions, whatever they are. Stepping onto a bus, not while he's sitting over his laptop crunching numbers, all right? Of course, he didn't have a laptop. Kary Mullis was driving through Northern California with his girlfriend when he got the idea for PCR, the polymerase chain reaction. So there's a number of these famous cases. They're not working on the problem, they're doing something else, and boom, this idea suddenly hits them, this creative insight. And many have referred to these as incubation effects. Poincaré, in fact, thought he was a psychologist, and he said it's the unconscious that's working on this and working on this. I guess because we are too stupid to do it. Thank goodness we have a smart unconscious to do this stuff. And then it produces these brilliant insights even when we're not at work. All right, so how is it possible? How do these things happen? The main hypothesis historically that people have worked on is, well, I'll get to that in a second. When I got to this puzzle, there had been 50 years of research on incubation effects, and there was not a single replicated finding of the effect. There were a couple of findings, there was almost nothing. And when the literature was reviewed in 1979, about the time when I got working on this, Olton said, well, there's really very thin evidence that this thing really exists. So why is that? Well, the reason, as I think you will see, is because of the unconscious work hypothesis. This is the hypothesis that everyone was working on. Everyone said it's the unconscious, and it works, 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 and then it produces this creative idea. You are fortunate. I found a picture of this process. Here it is. All right, the elves and the shoemaker. I don't know if they have this one in Canada, but the cobbler gets tired. He puts his materials out. He goes to bed. He wakes up. There's the shoes. Did this happen? How did this happen? Well, they stayed up one night and they see the elves doing all this work. This is like the unconscious is doing this unconscious work while you are sleeping. That would be really cool if it were true. So it kind of works like this. So incubation, you put eggs in an incubator, you leave them in there, and you leave them in there, and you don't see anything, you don't see anything, and then boom, this creature comes out of there, and you know it didn't start out that way, because if you had checked, you'd say, well, that's just a one-celled organism. So invisibly, all this stuff is happening and going on and going on. So this is why this effect is called incubation. This is a terrible name, and I'm going to work on a new name for it. Is there such a thing as unconscious work? Interestingly, there's no evidence for this. Here's another diagram of how it worked. You've got this level of consciousness, and you've got the problem. You work unconsciously, you input that, and it goes through an operation, and the results of the operation, another one, and then you say, I just thought of something, and that's the solution. Okay? There's no evidence that this happens. There is some evidence that people say, well, that is evidence of unconscious work, but it is much more easily, their observations are more easily explained by other theories. So I'm not interested in unconscious work. I just want to get it out of the way. And if you go away and someone says, what did he talk about? What causes incubation? And you say unconscious work, you went to sleep too early. So don't go to sleep yet, because we're just getting started here. Okay, so this is a great fable, but there's just no evidence for this. Well, what about, let's try another hypothesis. I call this the forgetting fixation hypothesis. And it says that the incubation effects and these sudden insights when you don't feel like you're working on a problem, those occur when you are able to get fixated responses or things that you're stuck on. You get them out of mind, at least temporarily, when you forget them. And you don't need unconscious work for this to work. And I'm not saying that unconscious processes don't exist. They definitely do exist, and we can map those, but they're really more like reflexes. They're not like some machine that cranks out answers to problems. Okay, so an incubation effect, it's insight after a break from a problem. Here's my logic. So you work on a problem, and if you solve it immediately, that's not an incubation effect. You just solved it. Then there's other problems where you'll never solve that problem. Incubation effects, they're irrelevant. It only is relevant for a problem that it is possible for you to solve. It's a tractable problem, but you don't get it initially. Why don't you get it initially? Well, I call that fixation, or some kind of a block. Something is blocking you from solving this perfectly solvable problem. And eventually you'll get it, but you've got to go through some other process. And that's what I focus on, the role of fixation in these sudden insights that seem to occur when we're not consciously working on any kind of a problem. So fixation is a block or an impediment or an obstruction. I'm going to give you a really simple example. You may relate to this. Here's a simple example. You've got this subject here. He's in a tea maze, and you tell him, okay, go find the cheese. And he runs up to the end of the tea maze, and he looks left, and he looks right, and he says, oh my God, a piece of cheese. And he gets the cheese, and he goes there, he turns right, problem solved. Wow, is that cool? You take him the next day, you put him back in the maze, and he does it again. He says, wow, I love this job. This is so cool. I just go up here, I turn right. That's great, let's try it again. Oh, did it again. This time I'm going to try walking backwards and then go the other way. It worked. Wow, this is great. I love this. I can close my eyes. I can go up there, and it works again and again and again. This is really useful. And stuff you learn is supposed to work this way. You learn it, and then you use it, and you use it, and you use it, and you use it again and again. Then another lab assistant comes in, and you say, hey, look, I trained this lab to find the cheese. Well, the other lab assistant said, well, let me try that. And they put the cheese in the other way. The rat goes up here, turns right, and says, oh my God, I must be asleep. I must be hallucinating. What happened? Let's try it again. Okay? No, it's not there. You look all around. It's not there. It's not there. What am I going to do? This is a big problem, and we can call this a very simple example of fixation. This is a fixation effect. If you stop doing the wrong thing, if you stop going the wrong way, that doesn't solve the problem. It just enables you now to solve a perfectly tractable problem. That's the model for fixation and creativity and insight. Any question? No. Okay. So I'm going to talk about this as we go. Fixation is often said to be caused by limiting assumptions that are implicit. What does implicit mean? It means unconscious. It means you're not aware of them. Well, here's an example. You've heard of thinking outside of the box. This is the box. You have to put your pen down on one of these. You draw 4 or fewer straight lines without picking the pen up and connect all the dots. So you say, okay, let's give that a shot. 1, 2, 3, 4. Dang, missed 2 of them. Let's try it again. 1, 2, 3, 4. Darn it, so close. Okay, so Gestalt psychologist said, well, they're staying inside the box. You have to go outside of the box to solve this problem, but people are not thinking of going outside of the box. Whether this is really true, I don't know, but here's how it works. If you give people, by the way, an 11-dot problem, it's easier than the 9-dot problem, even though it's the same rules. You go 1, 2, 3, 4, and then you've got it. So you have to go outside of the box in these 2 places. That's where the expression comes from. And the idea is maybe we implicitly limit ourselves from going outside that box. Here's another one. It's called the Lucan's water jar problem. You use these 3 jars. This one holds 21 cups, 127 cups, 3 cups, measure out 100. I'll give you the first one. It's going to be B minus A minus 2C, and that gives you the answer. Has anyone figured out the second problem? How to get 99? I'll give you a hint. It's B minus A minus 2C. I do the math for you, but you probably can do that yourself. Some of you are engineers. And then you try the third one, B minus A minus 2C. Cool, you're just like the rat with the cheese. B minus A minus 2C, oh, this is great, B minus A. And now you've become automated, and you automatically reapply this same formula again and again and again and again and again. Ta-da, my work is done. But there's a funny thing that happens when you look at number 7 here. Yes, B minus A minus 2C, that works. But there's a much simpler solution that's there. You just take 15 and add 3, and that's pretty straightforward. If you had no learning at all of B minus A minus 2C, you would have thought of that right away. And of course, the last one, if you do B minus A minus 2C, you get 42, and it's the wrong answer altogether. But there's a really easy answer. 28 minus 3 is 25. So this is sometimes called Einstellung or mental set, another example of what's sometimes called implicit fixation effect. Determining the area of this figure is pretty darn easy if you've been through the 8th grade at least. All right, so it's going to be, you add up the rectangle or the square, 4 times 4, you take base times half the height, and so on. For the triangle, you add them together. Ta-da, you got it. This is not an insight problem, but this one is. All right, so in this one, people try to divide and conquer, just like in all the other ones, but there isn't enough information in here to actually solve this problem if you're going to do it that way, because you can't really figure out the area of these little triangles. All right, but I'm going to give you a hint. If you looked at this hint, you'd say, oh, that's pretty easy. You just slide this one down. It's a rectangle. It's a 6 by 10 rectangle. Really easy. And so you have to redefine the problem. Okay, now, people get stuck on using things that work, and they work again, and they work again, and they work again, and that's nice. But then there's that special case where it doesn't work. Okay, so I'm going to talk a little bit about fixation research. Am I out of time yet? Oh, thank goodness, because I have 122 more slides. So fixation and creative problem solving. I started off with these rebus problems. This is just between you and me, and I gave people a clue between for those, and I give them a bunch of those problems, and, including between in lines for reading between the lines, 3 degrees below 0, and then we get to these two. I give them this rebus, and then I give them the clues paper and over to make them think of fly paper and overnight or something like that. Anybody know the solution to that one? That's a fly-by-night. Thank you. That's fly-by-night. And I give bad clues here, misleading clues, under the weather and whether or not you're supposed to think of. Anyone know this one? This one's a little tougher. That is an ill spell of weather. If you don't get that, you do all your work with your thumbs and you don't have a dictionary. Anyway, when we give people these misleading clues, guess what? They do worse because they're relying on these clues that make them worse. We tried this in another case with remote associate test problems. You have to think of one word that goes with each of the three test words, salad, head, and goose. I give them the helpful blocker, lettuce. You think of a lettuce salad and a head of lettuce. There's no goose lettuce or a lettuce goose, so that doesn't work. The solution to this one is egg salad, egg head, and goose egg. All right, and we devised a number of these kinds of problems, giving people these helpful blockers, not helpful at all. And what we find is they do a lot worse when we give them these blocker words than when they haven't seen any of those words at all. So this is remote associate test problems are considered creative problem solving. It's sometimes used as a test of creativity, but I would recommend that you don't use it as a test of creativity, but it's done that way. So we see this fixation effect in creative problem solving, and it's an effect that I can experimentally induce. I can give them the blocker or not give them the blocker, and I can see the effect in the experiment. Now, by implicit fixation, I have to tell you a little bit about, I'm going to do a little bit of a psychology lecture here, a little digression to explain what I mean by implicit cognition. In studies of amnesic patients, we learned about implicit cognition. So there's different kinds of amnesia. There's anterograde and retrograde. Retrograde is the soap opera kind, very useful in soap operas. You're born here, you die here, here's where you hit your head on the goalpost, and what happens is you forget some of the past, but then it comes back, and then in the future you're pretty much okay. That's not the amnesia I want to talk about. I want to talk about anterograde amnesia, where you're born here, you die here, here's where you have an injury to the hippocampus, which of course is where hippopotami go to college. Anyway, you have an injury to your hippocampus. In the rest of your life, you can continue to remember events from before that injury, but you can't form new memories that you can remember. And so this is 50 First Dates, this is Memento, that's what's going on here. For someone with anterograde amnesia, it seems like they have no memory. That's the symptom. This fellow, Edward, I can't pronounce his last name, Claparede, had a patient who was amnesic. She had anterograde amnesia. She would introduce herself every time she saw him. One day, he thought, you know what, I think she really can remember stuff. And he tries this thing. He puts a hat pin in his hand. He leans across the table. He jabs her in the hand. She says, ow, what'd you do that for? This is before there were IRBs. Okay. So he jabs her. He says, it's just a psychological test. And then much later on, he starts to lean across the table and she pulls her hands away. He says, why did you pull your hands away? She says, I don't know. Sometimes people conceal sharp things in their hands. She remembered it, but she didn't know. She couldn't consciously remember it. This is an example of an implicit form of memory that she still has intact, this unconscious form of memory. It's called automatic memory or implicit memory. These anterograde amnesics, you give them a list of words, they can't recall the list of words or who you are. But they can be tricked into using this implicit or automatic form of memory. So you give them the list, horizon analogy, unicorn vacuum. Then you say, recall the words. They say, what words and who are you? Okay, never mind. Complete these word fragments. Here's one. Here's another one. For most of you, the second one is easier than the first. It's not because it's easier. It's because it's right there. You just had it on the list. But unless you had tequila for lunch, you wouldn't know that one quite so easily. So there's an automatic form of memory that pops these things into mind. You don't have to be aware of it. You don't even have to have a hippocampus, really, to get that to work. So this is what I mean when I talk about implicit cognition. Cognition that works, but that you're not consciously aware of. Now, the anterograde amnesic can't use their conscious explicit memory for new events, but their implicit memory is intact. Normal people, if there is such a thing, have both intact, so we can test them all the time. One of the ways that we test them is using this word fragment completion test that I just showed you. You show them a list of words, you give them fragments. People can solve the fragments that they've recently seen better than the other fragments. So a word fragment completion test is sometimes referred to as an implicit memory test. So when I first started looking at these phenomena, I thought, does that always work for you? Could it work against you? My hypothesis was that this involuntary implicit memory can unconsciously block creative thinking, and that's what the old Gestalters meant when they talked about implicit blocks or implicit fixation. So I constructed analogies like this, word fragments like this. Show them the word analogy, give them a word fragment, and analogy doesn't fit. All right? And some people try and it doesn't work. If they haven't seen this so-called blocker, the target is really pretty easy for most people. It's allergy. But if you show them these word fragments, they can't do it. So this is a model of implicit fixation. If you've seen the word brigade, it makes baggage difficult to solve here. So I constructed a number of these, and you get what's sometimes called an implicit memory blocking effect, and this has been replicated in a number of papers elsewhere. Now, when you tell people, when they get these word fragments, just solve the fragments. We'll call that the standard instructions. Just solve the fragments. In the control condition, they get about half of them. When they get the blocker words, drops to about 33%, 17% blocking effect. Maybe they really are consciously remembering those other words. So I told people, try to remember those words that we showed you before. Maybe that'll help. And I love to do this because we love tricking subjects in the laboratory. It's the only thing we don't get paid much, but at least we can trick our subjects. So you tell them to remember those, the blocking effect goes up. So now they're using implicit and explicit memory together, and they both contribute to this memory blocking effect. If I tell them, forget those primes, they're all wrong, we're trying to trick you, we still can't get rid of the effect. It was a little bit smaller, but it isn't significantly less. So we can't get rid of the effect altogether. These blocks are involuntary. You can't help it. You can't consciously escape from those because your implicit memory is automatically delivering these solutions to mind. Now, does this work in something that is more like a creativity test? We told people create, sketch, and label parts of new life forms that might evolve on a planet similar to Earth. Half of them see no examples and away they go. Half of them see these horrible examples, which one of my lab assistants drew, and they're not very good. But interestingly, they all have 4 legs, they all have tails, and they all have some kind of headgear, antennae on their heads. Life forms do not have to have these features. You may want to think about that. Now, if they had, in the control condition, they gave those features about 11% of the time. If they saw the examples just for a few seconds, the use of those features, the use of 4 legs, the use of antennae, the use of a tail in whatever creative idea they came up with were much more common. So we refer to this as a conformity effect. Can't say we're really blocking ideas completely, but we're leading them to ideas that they've already seen, and they are copying these ideas. This conformity effect, in the standard instructions, we just say, creatures on another planet, go away, go and draw them. And so we get about a 25% conformity effect here, as in the case I just showed you. If maybe they think, oh, we're supposed to conform to those. So we tell them, those are great examples, try to do that. The conformity effect goes way up when they are consciously trying to copy them. If we say, give us stuff as different as possible, those are terrible, stupid examples. They cannot avoid that conformity effect. And these findings parallel the findings that we had just a minute ago with the implicit memory block. And so what it looks like is, in this conformity effect, people are automatically and unconsciously bringing to mind the examples even when they shouldn't be using them. Okay, so this conformity looks like it's a result, at least in part, of involuntary implicit memory that people can't avoid. With my colleague Jamie Shaw, we said, well, what do these lab experiments have to do with the real world? In lab experiments, it's highly controlled, simple tasks. You look on a single cognitive process, you look at an individual. If we're going to look at students in design classes, where it's a little more ecologically valid, how about the real world? Does this stuff that we're doing in the lab have anything to do with the real world, we asked. So we tried this in conceptual design tasks. Actually, the original was much earlier. We, with a colleague, David Jansen, we said, create, sketch, and label parts of a new measuring cup for blind people. Half the people saw no example, half the people saw this terrible example, which only has quarter cup increments. You can't get a third of a cup. It has no overflow device. If you have your eyes closed or if you're blind, you can't really see when it's going over. So it needs that. A design student is supposed to know that. And if they saw the example, they were more likely to use those bad features of the example, even though they shouldn't be doing it. So in the control condition, they are much more likely, in the fixation condition, they're more likely to give the non-infinitely variable one, have an overflow, things that are similar to the example. Okay, we weren't explicit enough. What if we tell people, don't copy this example? We tried this one. Create, sketch, and label parts of an inexpensive spill-proof coffee cup. Do not use drinking straws or mouthpieces. Half of the people saw an example that has a drinking straw and a mouthpiece. Okay, doesn't work very well either. If it tips over, just think about it, it flops over and it leaks all over your pants and you get to sue McDonald's. So what we found, though, is that if they saw the example, and even though we explicitly forbade them to use mouthpieces and drinking straws, they put them in there anyway. In the fixation condition, 39% of them leaked. Lots of them used straws. Lots of them used mouthpieces. Why were they doing that? Now, I should say this was published in 1992, 1, something like that, before your grandparents were born. So now people know what spill-proof coffee cups look like and what they do, so you need a new problem if you're going to do this. We said this only works with students, not with real engineers who are getting really paid, really big buck salaries. So we got a hold of some of those who said they would be in our experiment. We said, okay, we want you to devise an instrument that will take samples and measure what's going on in the intestine, all right? And half of them saw this example. This is a terrible example. Let's start with that cord. There's only 2 places that cord can go, and neither one of them is pleasant. So this is a bad design. And yet when we showed these to professional designers with real jobs, they're all giving us 100% with a control box. The front opening, which is a problem, it'll get turned around, and 78% of them had a cord in it. What's wrong with these people? Dock their pay. All right, so this works even with professional engineers, not just with students. So this is has been referred to as design fixation. It's been found lots of times since these experiments were done, and we think it's the result of this implicit use of examples that people have seen. Okay, I have about 9 minutes left. There's no way I'm going to get through all this, so I'm just going to pick a couple of things to focus on. So the idea that I started with is the idea that incubation occurs when fixated responses are kept out of mind. Here's one where we gave people, we made them fixated by showing them these blocker words, and then we gave them an initial test on the problem and a retest after a delay, and you only get an incubation effect if they've become fixated initially. Why weren't people seeing incubation effects in all those other studies before our work? They weren't doing any work to get people fixated in the laboratory. Here's another one where we gave people these misleading blockers or clues. We find an incubation effect. If you retest after a longer time, you get an improvement. An incubation effect, their memory of those blocker words goes down. So this looks a lot like the forgetting fixation effect. We see this in brainstorming. We also get an incubation effect in brainstorming only when we started off by causing a fixation manipulation. So, does this work in design experiments? We had people these weren't people, they were students who were in a design class, create novel vehicles for transporting and loading ping pong balls. We got some very routine kinds of ideas, and we got some interesting ones. And then we retested after and gave them another chance to do it either immediately or after a delay. And we get an incubation effect in if we measure the number of ideas, the variety of the ideas, the quality of the ideas, the novelty of the ideas. People did better in each case in the incubation condition. So we conclude that these effects are similar when you look at a real design problem as they were when we were looking at implicit fixation or fixation in creative problem solving. Okay, now we have a theory, and I think I'll skip the theory, although you might think it's fun. Maybe I'll just get us started. It involves hierarchically structured multidimensional vectors, which I'm sure you're familiar with. Here's a vector. It's just got 4 different dimensions, and the first one is coded in various ways, and the second dimension, the third dimension, the fourth dimension. And if you start off a search and you code 1, you're going to be at the first level. If you code 2 of those dimensions, you get here, and 3 and 4. And as you go, you get more specific as you go down. All right. So if your goal is to get this particular product, whatever it is, and you start here, you're going to start here and work your way down and work your way down, and now you're at your goal. Okay. If, however, your goal is over here, and I introduce a blocker or a lure in the first place, some of these dimensions are primed, now you're going to head down and you're going to be blocked, and you will not be able to get over to the goal. Why not? The reason is that down is easy. You just add you code a new dimension and you code another dimension, but to uncode a dimension is difficult, and it's a difficult thing, and that's called abstraction, thinking abstractly. Okay, so a conformity effect, as with our alien creatures, if we start by showing them a thing with a head, a tail, and 4 legs, then that's the direction that people go, and however you do it, you're going to end up with a head and a tail and 4 legs. So your final design just gets to this part of the what's called the ideation space. I'm going to skip over this, although it's great fun. But I will tell you that our subjects produce ideas that are pretty much like the ideas that you see in real science fiction. We did an analysis of these different dimensions, so they're kind of similar. But I'll skip that. In the theory of structured imagination, the path of least resistance says that you begin this kind of work by starting with a basic level category, and then you get more specific. So if I say, give me a creature for another planet, you might start with a basic level category of a dog, or could be of a horse, or a rodent, or a fish. And then you come up with the thing that was in John Carter of Mars. I guess that was not a big movie for people. If you say, create a new vehicle, well, you might start at the level of a car. So you're overly specifying the idea too early, and then you get to some kind of a car. Now, what's the solution to this? Well, the problem is we're in this part of the idea space, and the solution is over here. How do you get over there? Well, one way that you could do it would be through incubation or through abstraction or analogy, and I'll go through these quickly. In incubation, you just put it aside, and then instead of taking this turn down the wrong path, you might get lucky and go down one of the other paths, including the one that has a solution. In abstraction, the idea works like this. You start off with car, you get to this stupid car, and you say, wait a second, let me try to think more abstractly. So you go up to vehicle, and then you go up to transportation, and then you say, well, what about teleportation? Maybe that would work for Star Trek fans, okay? So abstraction will get you out of the part of the idea space that you're stuck in. Again, going down, getting more specific is easy and natural. Being abstract, that is a difficult thing to do cognitively. It is possible, but that's what's important to do. Analogy will help with doing this, and you can ask Professor Hsu about her work in biomimetic design using analogies from all kinds of domains. So if you use an analogy, you're taking something that is similar to your problem, but from another domain that you're already familiar with, or expert in. Julie Lindsay used what's called the word tree method. So you start, this is a device for folding laundry. Apparently, in design problems, they start with function statements that are mostly verbs. You plug those verbs into word tree, and you say, well, what is the next most abstract level? Change surface of, change. What's another example of that? And so you can get analogs, for example, from sailing in what you do with sails, for example. Here's a couple more of her problems. Design a problem for a coffee bean winnowing device or automatic cleaning of a self-cleaning litter box. You take clean, it goes up abstractly to remove, and then you look for other examples of that and draw from farther domains. So that's another way to get you out of that part of the idea space that you're trapped in. Okay, cognitive neuroscience hasn't done much, but in the future I think we're going to start seeing some work from cognitive neuroscientists. They've been looking at the default mode network or inhibition of the dorsolateral prefrontal cortex and other things like that. Getting people drunk is another one that does the same thing. And so we may see some future solutions coming out of there. Okay, so to conclude, cognitive mechanisms that underlie creative thinking include some of these that I've talked about. There is no unified, no unitary creative process that always works the same way. Instead, it's a flexible collaboration of the individual cognitive units, and each of these is contributing in its own way. There, I got Star Trek in there. Whew! Thank you.